So this is a compilation of about 20 of my YouTube shorts. For each video, I'll give you 3 math facts, but one of them will be a lie, and your job is to guess which one. I've put all 22 episodes in order, but the most recent ones, the ones near the end of the video, are much higher quality, so I would check those out first. Enjoy! Two truths and a lie, but with math. Can you spot the fake? First, Pascal's triangle has the Fibonacci sequence hidden inside it. Adding up the numbers along these diagonals results in every Fibonacci number. Second fact, pick a positive integer. Whatever number you picked, there is always a row completely made out of multiples of that number, excluding the ones, of course. Last fact, in each row, the sum of numbers 1, 3, 5, and so on equals the sum of numbers 2, 4, 6, and so on. The very first row is the only exception to this rule. Pause now to think about which fact is fake. The first fact is true. We can see that these 6 numbers perfectly add up to these 4 numbers, meaning the sum of these two diagonals equals the sum of the third diagonal. All the other diagonals are also sums of the previous two diagonals, which is the definition of the Fibonacci sequence. The third fact is also true, and also has a pretty neat idea behind it. We can decompose numbers 1, 3, 5, and so on into the previous row, since each number in Pascal's triangle equals the sum of the two numbers above. We can do the same with the rest of the numbers, and we get the previous row again, meaning that the two sums are identical. This means the second fact is fake. The proof is kind of long though, so I've linked it in the comments. Two truths and a lie, but with math. Can you spot the fake? First, this formula gives you the Fibonacci numbers. You can plug in any positive integer n and get back the corresponding Fibonacci number. Second fact, notice that 8 squared, 64, is 1 away from the product of its neighbors, which is 65. This is true for every number in the sequence. Third fact, the ratio between consecutive terms slowly gets closer to the golden ratio. And even if you change the starting terms to form a completely different sequence, the same thing happens. Pause now to think about which fact is fake. The third fact is true. Assume that the ratio between consecutive terms approaches r. This means that if one term equals x, the next two will be rx and r squared x. Each term equals the sum of the previous two, and solving this quadratic gives you the golden ratio. Nothing in this process has anything to do with the first two terms, so they don't matter. The fake fact was the first one. As we just saw, the Fibonacci sequence grows exponentially, so this quadratic can't keep up. But there is a formula, and yes, this does produce the right integer every time. The proof of the second fact uses algebra to show that if it's true for any one number, it's true for the next one as well. You repeat to infinity, and this strategy is called induction. Two truths and a lie, but with math. Can you spot the fake? First, take a Pringle-shaped piece of paper. Notice how it curves in two opposite directions, each the same amount. This means you can completely flatten the Pringle paper without scrunching it up. Second, every odd perfect square, minus 1, divided by 8, equals a triangular number, which are numbers that form, well, triangles. Third, you might think that creating a line of best fit minimizes the average distance between the points in the line, but the convention is minimizing the squares of the distances instead. I made a mistake here. The convention is to minimize the square of the vertical distance, not the normal distance. Pause now to think about which fact is fake. The third fact is true, and we'll go down to one dimension to see why. We have two dots and we're trying to find the quote-unquote dot of best fit. Using the least squares method, we find the obvious solution, but by using just the distance, any dot in between works because they all have the same average distance, so we don't know which is the best one. Second fact is also true. The reason why is really neat, so try using the dots to find the proof before I show it. Ready? Starting with the square, we remove the middle dot, divide by 4, then divide by 2 again, ending with the triangle. The first fact is fake. I just made it up. You can't reshape paper into a ball without scrunching it up, and this is sort of the same thing. Two truths and a lie, but with math. Can you spot the fake? First, in Pascal's triangle, it's pretty obvious that the middle numbers are bigger than the rest. But this isn't because of symmetry. In fact, if we mess with one of the rows to make the triangle asymmetric, the biggest number still settles back to being in the middle. To clarify, I mean the very middle, the biggest number touches the line of symmetry. Second, the sum of the numbers in each row is always exactly double what it was in the previous row. By the way, these facts apply to all modified triangles. This is just an example. Third, the only numbers that show up infinitely many times are the two on the outside. Pause now to think about which fact is fake. The second fact is true. If we decompose the second row, we see that each number in the first row appears exactly twice, so the second sum is double the first sum. The third fact is also true. Since the internal numbers strictly increase as you go down the rows, any number that you can name, besides these two, will eventually become too small to ever appear again. This means the first fact is fake. If we zero out part of the starting row, we see that this whole thing is basically the sum of multiple Pascal triangles. And if we make this number really big, the other triangles don't really matter anymore, and the biggest number of each row stays over here, away from the center. Two truths and a lie, but with math. Can you spot the fake? First, given two regions, you can always cut both in half using a single cut, no matter how ridiculous looking the regions are. They can even be disconnected if you want. Second, twin primes, which are prime numbers that are 2 apart, always add up to a multiple of 12. The only exception to this rule is the pair 3 and 5. Third, it's always possible to cut a 3-sided triangle into 4 identical parts, but not a single 4-sided quadrilateral can be cut into 3 identical parts. Pause now to think about which fact is fake. The first fact is true, and here's why. Focus on one region for now and notice the infinite number of lines that cut it in half. Now pick one of those lines at random and look at the second region. Let's say 20% of its area is on this side of the line. Now we are going to rotate through all the lines from earlier until we've rotated 180 degrees back onto our original line. Now, since we're backwards, 80% of the second region's area is on this side instead of 20%. This means that somewhere in between there was a line with 50%, so this line is exactly what we're looking for. The second fact is also true. If we arrange primes in a table by remainder when divided by 12, we can see that all primes besides 2 and 3 fall into these 4 columns because these 6 columns are even and these 2 are divisible by 3. As a result, all twin primes must either have remainder 5 and 7 or remainder 11 and 1. Either way, the sum has remainder 0, so it's divisible by 12. I made the third fact up, and it's easier to see this by working backwards, starting with the parts and building the quadrilateral from there. Two truths and a lie, but with math. Can you spot the fake? First fact, given a bunch of points, the smallest enclosing circle is unique. There is no other circle the same size that also contains every point, even when you change the points up. Second fact, the smallest enclosing circle goes through at least 3 points, of course assuming there are at least 3 points available. Third fact, the radius of the circle is always less than the largest distance between two of the points. Pause here to think about which fact is fake. The first fact is true. Let's prove it by contradiction. Assume that there are two smallest enclosing circles. Both of them contain every point, so all points lie in the intersection. But if this is the case, then we can just make a smaller enclosing circle, which is a contradiction. The fake fact is the second one. Here's an example. As you can see, the points are clustered toward the center, so if you force the circle to go through one of them, it'll end up bigger than necessary. So the third fact is true. Let's focus on the points on the circle to get a rough idea why. Notice that they can't all be on the same half, because then you can make the circle smaller. This means they're spread out enough so the largest distance between them is greater than the radius. Two truths and a lie, but with math. Can you spot the fake? First fact, your friends have more friends than you mathematically. This is because people with more connections are more likely to be connected to you. Second, take a strip of paper made up of colored squares. It's possible to fold the colors into any order that you want, and this works for any number of colors. Third, given a 6-digit number, split the number in half and find the difference. If this new number is divisible by 13, then so is the original. The same goes for 7 and 11. Pause the video now to think about which fact is fake. The first fact is true. People with more friends are more likely to be your friend compared to people with less friends, creating a bias. The second fact is fake. You might think that you can just connect the colors in the order that they appear on the strip of paper, but this might lead to the paper going through itself. The third fact is true. When we found the difference here, what we really did was subtract a multiple of 1001, which equals 7 times 11 times 13, because subtracting a multiple of 13 does not change whether or not a number is divisible by 13. This is a valid divisibility test. Two truths and a lie, but with math. Can you spot the fake? First fact, any line going through the center of mass will divide the object in half by area. This works for any 2D object as long as it's all in one piece. Second, take a look at this infinite sequence. None of the numbers are prime. Third, if you're climbing up a staircase and you can either take 1 or 2 steps at a time, the number of ways to get to the top is a Fibonacci number. The amount of stairs tells you which one. Pause now to think about which fact is fake. The second fact is true because each of these numbers can be cleverly manipulated into being the product of two different numbers, meaning everything in the sequence is composite. The third fact is also true. Work backwards. To reach the top stair, we can either get to the penultimate stair, then take a single step, or get to the stair before that, then take a double step. So the number of ways to get to the top stair is the sum of the number of ways to get to the previous 2 stairs. This is exactly how the Fibonacci sequence works, and since the starting terms are the same, every term ends up matching up. The first fact is a common misconception. Think about a seesaw. Being balanced doesn't mean that the two sides have equal area, as you can see here. So if you have an L shape with center of mass here, a vertical line will not split it evenly despite the shape being able to balance on this point. Two truths and a lie, but with math. Can you spot the fake? First fact, the bouncing DVD logo cannot hit the same corner twice in a row. It needs to hit another corner first in order to return. Second, take a look at this chessboard. It's pretty easy to cover it with dominoes, but if you remove two opposite corners, it's now impossible to completely cover it without overlapping dominoes or going off the chessboard. Third, take 3, which is a prime number. Cube it, then subtract 8 to get another prime number. You can keep doing this to end up with infinite prime numbers. Pause now to think about which fact is fake. The second fact is true. Notice that each domino covers one black square and one white square. So by removing 2 white squares, we destroyed the balance and will always have 2 black squares left over, with no way to get rid of them. The first fact is also true. In order to return to this corner, the logo must perfectly retrace its steps. But how are we going to get the logo to turn around? Hitting a wall won't work, so our only option is hitting another corner, which does indeed force the logo to do a 180. This means the third fact is fake. 8 happens to equal 2 cubed, which means we can cleverly factor this expression. Since we now know the number has these factors, it can't be prime, so the fact is false. But there is a similar fact that is true. If you take this number, called Mills's constant, and cube it again and again, then remove everything past the decimal point, you'll get infinite prime numbers. Two truths and a lie, but with math, can you spot the fake? First fact, measuring the length of a coastline sounds simple, but mathematically, there is no right answer. This is because coastlines behave like fractals. The perimeter depends on the level of detail. As a result, official sources often disagree with one another, sometimes by crazy amounts. Second fact, a cube has multiple different nets that can fold up into a cube, but tetrahedrons only have this one net. These other nets end up forming different shapes. Third fact, imagine a wooden Rubik's Cube with a termite starting in the very center. It's impossible for the termite to burrow through all 27 cubes. Moving diagonally or going back to previous cubes is not allowed. Pause now to think about which fact is fake. The third fact is true. We'll color the cubes in a checkerboard pattern so that white cubes can only touch black cubes and vice versa. This means that every time the termite moves through cubes, it switches colors. Now, notice that there are 13 black cubes and 14 white ones, meaning a path going through all 27 must start and end with a white cube. But the center starting cube is black, so this is impossible. The first fact is also true. The further down you look, the more detail you see, and the more detail you see, the longer the coastline becomes, and every source stops at a different point. This is known as the coastline paradox. This means the second fact was the fake one. This long net actually can fold into a tetrahedron. Two truths and a lie, but with math, can you spot the fake? First fact, every polygon can be triangulated, meaning completely divided into triangles only. You don't even need to add extra vertices. Second fact, take the midpoints of a polygon's edges and connect them all up. This new polygon will always have less area than the original. Just like the first fact, this is true for every polygon, convex or concave. Third fact, let's say I have a pile of coins and you have the same pile, but with one extra coin. Now if we both flip all of our coins, the probability that you get more heads than me is exactly 1/2. Pause now to think about which fact is false. The first fact is true. Every polygon has at least one ear, which is a vertex that sort of sticks out of the polygon like an actual ear. You can create a triangle with the ear and the two vertices neighboring it. This will leave you with another polygon and you can repeat the process until you've triangulated the whole thing. The third fact is also true. Notice that if you replace heads with tails, the question is still basically the same. Now notice that saying more tails is the same thing as saying less or equal heads, since if you have a lot of tails, you'll only have a few heads. So now we know more heads and less or equal heads have the same chance of happening, and since you must have one or the other, the probability for both is 1/2. This means the second fact is false. The trick is to use a thin polygon to minimize the original area while still spacing out consecutive vertices so that the midpoints are far enough apart. Two truths and a lie, but with math, can you spot the fake? First fact, a clock will never have all three hands equally spaced apart. Of course, the clock can't be broken in any way, and all hands move continuously without ticking. Second fact, take a rectangular grid, then draw on the diagonal. The number of tiles touched by the diagonal is always equal to the number of tiles on the border of the grid, which is a plus b minus 1. Third fact, draw a parallelogram, then pick any point inside. Color the triangles like this. The blue area always equals the green area. Pause now to think about which fact is fake. The third fact is true. Remember that triangle area is calculated using base and height, so if you don't change either value, the area remains constant. After some more clever manipulation, we see that the blue and green areas are equal. The second fact is false. By doubling the size of the grid, the diagonal touches double the tiles. So if the formula were true, then 2a plus 2b minus 1 would be exactly double a plus b minus 1, which it's not. So we need to adapt our formula to make sure it stays true when this happens. The solution is replacing 1 with greatest common divisor, which measures how many of these there are and overcounts accordingly. This new formula does work for every grid size. This means the first fact is true. Let's start by testing out simpler clocks. Here, the fast hand is moving 4 times the slow hand speed. Now look at when the hands overlap. It happens not 4 times, but 3, one less than 4. Now look at when the fast hand is 120 degrees ahead of the slow hand, which is what the fact was originally about. Again, this happens 3 times. Another example, 5 times the speed, 4 overlapping positions. And if we look at 120 degrees, also 4 positions. Can you see the pattern? Now back to the original question. The minute hand moves 12 times the speed of the hour hand, meaning 11 of those 120 degrees positions. The second hand moves 60 times the minute hand speed, meaning 59 of those 120 degrees positions. Those numbers are not compatible, so you can't have both of them at the same time. Two truths and a lie, but with math. Can you spot the fake? First fact, shine a laser inside a rectangular box whose walls are mirrors. The laser will always eventually return to the exact spot where you fired it, no matter how you angle or position the laser. Second fact, flip a coin until you get 2 heads in a row. Now take another coin and flip it until you get heads followed by tails. On average, getting heads will take longer than getting heads tails, which is unexpected because they have the same chance of happening. Third fact, take a 3 by 3 grid, then connect the dots like this. Interestingly, these 5 regions all have the same area, which is strange because there's no fivefold symmetry here. Pause now to think about which fact is fake. The second fact is true. Let's say you're aiming for heads tails and you just flipped heads. If you then get tails, you're done, but if you don't, you immediately have another chance to. Compare this to heads heads. If you just flipped heads, but you fail to get another, you can't immediately try again. You have to wait for another heads. So heads tails is easier to get. But aren't they both a 1 in 4 chance, so they should show up equally often? They in fact do, but notice that heads tend to show up in chunks. This is because it's possible to have them right next to each other. You can't do this with heads tails, so they're more spaced apart, making them easier to run into. The first fact is fake. The key is irrational numbers. Here's an example with a 1 by pi rectangle. After bouncing on the top wall, the laser's y value gets contaminated with pi, so it'll never return to its original corner with a y value of 0. The third fact is true. The 5 comes from the Pythagorean theorem, and if the side lengths have 5 in them, then so will the areas. 2 truths and a lie, but with math. Can you spot the fake? First fact, take a flashlight and point it straight up, parallel to a wall. The lit up area will trace out a perfect parabola, which you can see here in red. Second fact, draw a quadrilateral and its diagonals. After finding the area of these 4 triangles, we see that the areas across from each other multiply to the same number. This works for every convex quadrilateral. Third fact, a plane makes a round trip flying at a constant speed. Now, if the plane makes the same trip but with constant wind that affects the speed of the plane, the trip always takes longer than without wind. Pause now to think about which fact is fake. The third fact is true. You might think that going slower and going faster perfectly cancel each other out, but if you're going slower, you're taking longer, meaning most of the time on your trip is spent going against the wind. This is true no matter what direction the wind blows, so having calm skies is always better. The second fact is also true. Here's the general idea. All rectangles work because all 4 triangles have the same area, so the products are equal. Now if I extend this line, these 2 triangles both get their area doubled. This doubles both products, so they're still equal. Every quadrilateral can be obtained using this strategy. This means the first fact is fake. This becomes more obvious if you bring the flashlight closer to the wall. Parabolas have a U shape with both ends of the curve pointing up, instead of a V shape with the ends pointing off to the side. This is called a hyperbola instead. 2 truths and a lie, but with math. Can you spot the fake? First fact, it's impossible to fold book pages so that when you close the book, both corners of the page stick out. You can only get one corner at a time. Second fact, it's also impossible to fold pages so that the page number on the bottom right corner is visible with the book closed. In this example, even though you can see the corner, the wrong page number is showing. The one you want is on the back. Also, for both facts, the book must be taller than it is wide. Third fact, if you have a circle inscribed in a quadrilateral, the sums of opposite sides of the quadrilateral are always equal. In this example, 5 plus 8 equals 6 plus 7. Pause now to think about which fact is fake. The first fact is true. Look at the distance between the 2 corners. Notice that this distance always stays the same or decreases, because increasing the distance would rip the paper. So if you get one corner to stick out, this constraint drags the other corner into the page. But couldn't it go here? No, because there's another constraint here, and here. These 3 constraints ensure that at least one corner stays inside the book. And forget about going here, the book itself is in the way. The third fact is also true. Let's simplify the diagram. These 2 lines have equal length by symmetry, so we'll give them the same color. Repeat for the other 3 vertices. Now we're just trying to prove that red plus orange plus blue plus green equals blue plus red plus green plus orange, which is always true since you can rearrange one into the other. This means the second fact is fake. You can scrunch the paper like this. This is effectively 2 folds, which sort of double negatives the page number back to the front where it is visible. 2 truths and a lie, but with math. Can you spot the fake? First fact, draw a right triangle with whole number side lengths, then draw the largest possible circle that fits inside. This circle will always have a whole number radius. This works for any Pythagorean right triangle. Second fact, pick 2 random points on a line segment, then find the distance between them. On average, this will equal half the line segment's length. Last fact, shuffle a full deck of cards, then pick one at random and make sure it's not a joker. On average, your card will be between the 2 jokers 1 in 3 times. Pause now to think about which fact is fake. The third fact is true. Let's say you pick the 16th card and the 7th and 40th cards were jokers. Now there's an alternate universe out there where you pick the 7th card and the 16th and 40th cards were jokers. And there's yet another alternate universe where you pick the 40th card and these two were jokers. But there are more universes, 3 more that correspond to positions 7, 16, 41, and so on, 3 universes for every possible trio of numbers. Now notice that in every trio of universes, exactly one has the joker sandwich that we want, so it'll appear 1 in 3 times, which is what the fact says will happen. The second fact is false. To make things easier, we'll choose from 11 points instead of infinitely many. So the minimum distance is 0 and the maximum is 10. So on average, your distance would be 5, right? No, because there are more possibilities for shorter distances. For example, there are 10 segments of length 1 but only 2 segments of length 9, so you're more likely to end up with a distance that's smaller than 5. The same idea works for infinitely many points, so the average distance is actually 1/3, not 1/2. There's a more clever solution that involves adding an extra dimension, but I won't get into it because it is harder to understand. The first fact is true. Some clever algebra gives us this formula. Now suppose a and b are even, which means a squared and b squared are also even. Adding them together gives c squared, and if that's even, then so is c. Adding and subtracting even numbers will always get you another even number, so the numerator is divisible by 2. The other 3 cases follow similar logic, so the radius is always an integer. Comment whether you got it or not. 2 truths and a lie, but with math. Can you spot the fake? First fact, out of every possible shape, a circle contains the most area for its perimeter. What I mean by that is, if you draw a bunch of different shapes with the same perimeter, the circle always encloses the most area. Second fact, you can always find 2 locations 10,000 miles apart that have the same exact temperature. In fact, you can replace 10,000 miles with any distance that you want, and this will still work. Third fact, take a needle and our goal is to get it to point the other way. Now look at the area swept out by the needle as it moves. No matter what path you make the needle take, you cannot reduce this area. You can move the needle around, rotate it however you want, but you still won't be able to beat simply rotating it 180 degrees. Pause now to think about which fact is fake. The second one is true. Start by picking 2 random points 10,000 miles apart and color in the warmer point with red. Now we're going to rotate our points while keeping track of their temperatures, which will change as we move them around. After half a rotation, the points have switched spots, but not only that, they've switched temperatures. The red point used to be warmer, but now it's cooler. So somewhere in between, the red point had to have been between warmer and cooler, that is, the same temperature as the other point. So that somewhere is exactly what we're looking for. And of course, this works for other distances as well, not just 10,000 miles. The first fact is also true, and fun fact, the ancient Greeks knew this but couldn't prove it. And in fact no one could until the mid-19th century because the proof turns out to be surprisingly complex. For that reason I won't discuss the full solution here, but finding the answer is pretty intuitive. Just take a string, or imagine one in your head, and try to wrap it around as much stuff as possible. You'll end up with a circle-like shape. This means the third fact is false. An equilateral triangle works and has less area, as well as this shape called a deltoid, which has even less. You can actually get any area, no matter how small, but that's a pretty deep rabbit hole, so I'll save that video for later. 2 truths and a lie, but with math. Can you spot the fake? First fact, every single quadrilateral can cover a flat surface with infinite copies of itself, leaving no gaps in between. This is called a tessellation of the plane. Second fact, shine a laser pointer inside a circle whose walls are reflective. No matter where the laser is or what direction it's pointing, there will always be a region it can't get to, even if it bounces around forever. Third fact, draw 3 lines, then count every intersection point, even if they're really far away. The maximum is 3 intersections, but notice that every number less than 3 is also possible. 4 lines have 6 maximum intersections, and again, every number less than 6 is also possible. This continues to be true for any amount of lines. Pause now to think about which fact is fake. The second fact is true. Let's split the problem into 2 cases, which is a good strategy to use for math problems. First case, laser goes through the circle's center. If this happens, it will just bounce right back to the center and repeat this cycle without ever entering these 2 regions. So now let's consider the second case, which is when the laser does not go through the center. Notice how this diagram is symmetrical down the middle. This implies that both laser segments are equally far away from the center. This continues as the laser keeps bouncing. Each laser segment is the same distance from the center, so any point closer than that distance will remain laser-free. The first fact is also true. Notice that a quadrilateral is just 2 triangles, and since the angles in a triangle add up to 180 degrees, the angles in a quadrilateral add up to 360. 360 degrees is a full rotation, so you can fit 4 quadrilaterals around a vertex without any gaps, as long as you use each angle once. Also notice how new vertices have been created, and you can do the same thing again, and again, and again. You can do this with any type of quadrilateral, even concave ones. So the third fact is fake, and a simple counterexample is 4 lines. It's impossible to get exactly 2 intersection points. Try it yourself. 2 truths and a lie, but with math. Can you spot the fake? First fact, if you compare these two numbers, the one on the left is greater. This works no matter how you split the number, or even which number you use. Second fact, draw a regular hexagon along with a point inside. If you color these 6 lines, red, blue, red, blue, red, blue, the sum of the red lengths always equals the sum of the blue lengths, no matter where your point is. Third fact, a Venn diagram using 4 circles is mathematically impossible. With 3 circles, you can find any combination of letters, but with 4 circles, there will always be some combinations missing no matter how you arrange the circles. Pause now to think about which fact is fake. The third fact is true. There are 16 different combinations of letters, so we need 16 regions in our Venn diagram to fit them all. But is this possible with 4 circles? Let's see. Start with one circle which has 2 regions, inside and outside. Now add a new circle. Notice how it cuts the inside in half and the outside in half, so we now have 4 regions. Keep going. Our third circle cuts all 4 regions in half, for a total of 8 regions. But now, no matter where we place our fourth circle, we can't cut through all 8 regions to get 16. 8 regions is just too much, and our circle will inevitably miss a couple of them. And since 16 regions isn't possible, neither is 16 different letter combinations, so there will always be some combinations missing. The first fact is also true. Here's an example to help you understand why. 845 is greater than 800, which equals 8 times 100, so it must also be greater than 8 times 45. Another example, 1956 is greater than 1950, which equals 195 times 10, so it must also be greater than 195 times 6. You can repeat this process again and again to split the number as far as you'd like. The second fact is the fake one. Consider an extreme scenario where the point is very close to a vertex. This causes one of the blue lines to disappear, so the red length ends up being significantly greater. The fact does work sometimes though, but only when your point is on one of these 3 lines because of symmetry. 2 truths and a lie, but with math. Can you spot the fake? First fact, pentagons cannot fill up space properly, they always leave gaps in between. And I mean any type of pentagon, not just regular. If it has 5 sides, it won't be able to tile the plane, there will always be gaps. Triangles, on the other hand, can always tile the plane. No matter what the triangle looks like, you'll be able to neatly fit copies of itself together, like puzzle pieces. Third fact, look at this infinite sum. Rearrange the terms. Surprisingly, the sum changes, it's no longer 0. Let me repeat that. We didn't add any new terms in, or take any away. The only thing we did was put them in a different order. Turns out, just that alone is enough to change the sum. Pause now to think about which fact is fake. The third fact is true. To evaluate an infinite sum, you just add and subtract the terms repeatedly. As we keep doing this, we approach 0, so that's our answer. Now what if I don't want that to be the answer? I want it to be, say, 2. Can I really change the answer just by rearranging the terms? Let's see. We'll add 1, of course, but let's not subtract 1 yet. That's going in the wrong direction, so we'll save that term for later. Let's keep adding until we're above our target value, crossing out the used terms as we go. Now let's subtract 1. And we'll repeat this cycle, adding until we go above the target value, then subtracting until we're below it. We do this infinitely many times, thereby using up every term, and there we have it. This new sum approaches 2. Is there a problem with what we did? Well, I don't see anything wrong here. We didn't add in any new terms, we only used the old ones, all of which were used exactly once. What else could be wrong here? Maybe somewhere during the process we ran out of positive terms, so we were forced down to 0? No, that can't happen. We have infinitely many terms, and if you keep adding them, you're guaranteed to get back to the target value. So this seems to actually work. If this is still confusing, which is very understandable, the lesson to learn here is, infinity will screw with your head and there's not much you can do about it. Alright, first fact, false. Here are a couple examples of pentagons that do work. Fun fact, a researcher from a prestigious university claimed to have proved that there were only 8 types of pentagons that worked. Then, someone with a high school math education found 4 more types. I think there's another lesson to be learned there. Anyway, second fact, true. Triangles form parallelograms which fit neatly together, as you can see here. 2 truths and a lie, but with math. Can you spot the fake? First fact, folding a piece of paper always decreases its perimeter. As you can see, the unfolded paper has a longer outline than the folded one. This is true for paper of any shape as long as you do a simple straight line fold, none of those complex origami techniques. Second fact, not only does the perimeter decrease, the area does as well, and it decreases by the exact same ratio. Here, both decrease by 20%, and if you fold it like this instead, both percentages change but they're still the same. Just like the first fact, this works on paper of any shape. Third fact, a mathematician traps you on a large chessboard where you can only move up, down, left, or right, not diagonally. Your goal is to escape, but before you do, you must visit each square exactly once. Turns out this is impossible. No matter which path you choose to take, you'll either miss a square or visit one twice. Pause now to think about which fact is fake. The third fact is true. Notice that if you're on a white square, you're forced to move to a black one and vice versa. So, since the starting square is white, the second square must be black. But this means the third square is white, meaning the fourth square is black, and so on. See the pattern? Regardless of the path taken, odd-numbered squares are white, and even-numbered squares are black. This means the white escape square must be odd-numbered. But if we were to visit all 64 squares once, the last square, the escape, would be even-numbered instead. We have a contradiction, therefore we can't visit every square. Here's another way to think about it. Near the end of your journey, you'll be left with 2 black squares and the white escape square. Going to either of these black squares will leave the other out of reach, so visiting both of them is impossible. The first fact about perimeter always decreasing is also true. Pay close attention to the perimeter as I make the fold. Now, to get to the new perimeter, we must remove this red portion and add in this green part. Notice that we subtract more than we gain, so the perimeter decreases. But why is the red length longer? Let's try another example. Can you see the pattern? The green length is always the fold line, and the red length is always connected to it. The green length is a straight line, the shortest distance between 2 points, so it's always shorter than the red length. Therefore, we always subtract more than we gain, so our perimeter decreases. The second fact about area and perimeter is false. In fact, it's so false it took me a while to find a shape to use as an example. Pretty much any other shape will disprove the fact. Two truths and a lie, but with math. Can you spot the fake? First fact, you might know that soccer balls are made from pentagons and hexagons, but you probably didn't know that any combination of regular polygons can form a ball shape. Here are some examples. Some combinations can even form multiple different solids. Second fact, these two rhombuses are called Penrose tiles and they're famous for being able to fill space forever without forming any sort of pattern. In other words, this tiling looks completely random and it never repeats. But there is a way to force them into a predictable pattern. You just need to arrange the rhombuses in the right way. Third fact, draw any quadrilateral and pick a point from each side. If you pick the right points, they'll connect up into a perfect rhombus with all 4 side lengths being equal. You can do this for any quadrilateral, convex or concave. Pause now to think about which fact is fake. The third fact is true, and here's a visual proof. The first fact is the fake one. To create polyhedra like these, you just take some polygons and fold them into the third dimension. For example, 3 squares form the backbone of a cube. The key insight is that you need at least 3 polygons to do this. 2 squares don't really fold up into anything, as you can see. So if I give you a combination like octagons and dodecagons, it's physically impossible to fit 3 of them together like you can with squares. They're just too fat, so you can't fold them up into a polyhedron. The second fact is true. The Penrose tiles are rhombuses, so you can just lay them out into a long strip and attach those strips to each other. Of course, this isn't the only predictable pattern you can make. The point is, Penrose tiles have the ability to tile periodically as well as aperiodically.